Okay, YouTube, in this video we are going to be discussing how to solve a trig equation in which we have two different types of trig functions, but unlike my last video in which we had one of the trig functions as being squared, which allowed us to do a Pythagorean substitution and at least make the entire equation consistently one type of trig function. In this case we have two different types of trig functions. You see our cosine and sine, and neither of them is squared. So as a matter of fact, you see the title of the video here is Squaring to Convert It to a Quadratic Type. And that's going to be our method. So when we're in a situation where we have more than one type of trig function in which neither of them are quadratic, then what we'll do is this: we'll square both sides. And so let's go ahead and get started. I just want people to see what this looks like. So when we say square both sides, we mean square both sides, the entire side. So the right side is clearly simpler than the left side here. We end up with sine squared of x. And on the left side, we actually have to square this binomial out. So we say cosine of x plus 1 times cosine of x plus 1. And so squaring this out, we get cosine squared of x plus cosine of x plus cosine of x, so plus 2 cosine x. Let me make that a little bit more cosmetic here. Plus 1. And this equals sine squared of x. And so now we have two squared functions here, but you can see, I hope you can see, that it would be clearly more beneficial to substitute in Pythagorean-wise for our sine squared of x over here, substitute in 1 minus cosine squared of x, which is what sine squared of x equals, given that our Pythagorean identity says cosine squared plus sine squared of an angle is equal to 1. We say, well, then we know sine squared would be that 1 minus the cosine squared. So we're going to go ahead and perform this substitution. So we get on the left cosine squared of x plus these two cosines of x. Plus 1, and on the right here we have 1 minus cosine squared of x. So now we are consistently all in terms of cosine, so now the method's going to be this. Let's make it a quadratic type, that is, let's set it equal to 0 and attempt to factor it. And if it's quadratic and we can't factor, we'll just use a quadratic formula anyways. So that means we need to subtract 1 and add cosine squared, and that means we need to do the same thing over here. So minus 1, add the cosine squared. And so on the right, we are left with nada, that is 0, nothing. And then on the left-hand side, we have 2 now, 2 of these cosine squareds, plus 2 cosines of x. And the nice thing here is actually that our constant kicks out. So if I were to ask to solve this, it's technically plus 0 here, but, factoring this, we just say we'll just take out the greatest common factor. I mean, you should always check for GCF first. These both have a 2 and a cosine in common. So if we take out 2 cosine of x, out front here, then we're left with this cosine of x right here, and then 2 cosine x divided by 2 cosine of x is just plus 1. And so now we have this expression, it's a factored expression, a times b, say, equal to 0. So we can go ahead and set each individual factor equal to 0. That is, we have 2 cosine of x equals 0, or cosine of x plus 1 is 0. And solving these individually now, we can say, well, divide by 2. We get cosine of x equal to 0. Go ahead and do the cosine inverse, or the arc cosine of both sides. So we say then just x would be equal to cosine inverse, or arc cosine of 0. And we say, well then where would cosine be 0? And we say, well, cosine is 0 where x is 0, and that happens at pi halves and 3 pi halves. So we say for this equation we get pi halves, and 3 pi halves. So now, technically, let me erase this one here, or at least put it elsewhere. We say 3 pi halves, and we have to add on 2 pi n. That is, add on multiple coterminal angles, and we say adding on 2 pi, multiples of 2 pi, because cosine has a period of 2 pi. Then we're going to come back to these answers. For the first time, I'm actually in this series of videos that I've been making, I'm going to ask us to check these answers on purpose. We'll find out why. But we say, okay, so solving this guy here, we say subtracting 1 from both sides. We end up with cosine of x then. Cosine of x equals negative 1. So we'll undo our cosine using the cosine inverse. Just x, and x equals cosine inverse. Sorry, I'm going to put it down here. I just didn't, well, I suppose I could write it up here. Of negative 1. So we say, yes, where is cosine equal to negative 1 at? Well, where our x values are equal to negative 1, and that's at a pi radian measurement. We say this is pi plus 2 pi n. Groovy. So just wanted to check these answers to make sure that they actually work out. And the reason why is because we actually squared out everything that we had started with. And so it is the case that when you square something, you tend to lose some negative stuff from time to time. So going back to the original equation, we said, all right, so cosine of the angle plus 1 equals sine of the angle. That is, I just took out the x's from over here, and I'm going to drop in our answer. So we say pi halves. If I were to put in, say, pi halves here, pi halves, we get, just make sure this works out here. We say cosine of pi halves is 0. So we say, oops, 0 plus 1 equals sine of pi halves. And sine of pi halves, you can see here, is 1, clearly 1. So 0 plus 1 equals 1. And of course, this checks out. So pi halves is actually one of our keepers. This is one of our solutions. When we check 3 pi halves, I'm just going to go ahead and spill the beans here. We say cosine of 3 pi halves. This is going to be the one that doesn't work. But we say, we got to show you. So 3 pi halves. And here, 3 pi halves, 3 pi halves. We say cosine at 3 pi halves. Cosine at 3 pi halves, of course, is 0, 0. So we say, all right, well, doing a little dance here. We say 0 plus 1. And sine at 3 pi halves is negative 1. So we say we get 0 plus 1 is negative 1. Of course, this doesn't work out. So what this means is, even though you found it, it is not a solution to this equation. And of course, what I'm going to tell you is this one. This one is also correct. It is valid down here, the pi plus 2 pi n. I just want you to know, though, you should be checking all your answers when you do this square things to convert to a quadratic type kind of method. Okay? Okay.